All right, Algebra Squad, here we go. This is the second part for this video. We're going to check our work over here. This is what I left you off last time. Let's go ahead and check it out. So last time I looked at these numbers and I said, okay, this is a linear chart. It's not asking us to check if it's a linear chart, but it is. We were able to find the pattern of addition. So let's go ahead and find the rate of change. But to find the rate of change, all you have to do is find 2 points. It doesn't matter which 2 points you want to find. As long as you find 2 points and you label them x1, y1, which is your x and your y point from your first point, and then your x and your y, x and y from a second point. Okay? It doesn't matter which ones you choose. Does not matter. This is a line. A line will have the same slope throughout the entire existence. So I'll go ahead and choose this one right here. And hopefully there's a great chance that I chose different numbers than you guys. So here are going to be my x1, y1, x2, y2. So I'm going to go ahead and write them. Actually, what I'll do is I'll move this here and this here. I know that you have limited amount of space on your worksheet, so maybe it's best to watch to see how much work we have. I mean, you should already have this done. So to find slope of a line, you need to get 2 points and then grab their y's and subtract them. So y2 minus y1 divided by x2 minus x1. So if I go ahead and follow this, slope of this line is my y2 is going to be 19.92 subtracted by this one right here, 28.22. And 6 subtracted by 8.5. Hopefully you see that we're going to get a negative over a negative because 19.92 is less than the 28 number and 6 is less than the 8.5 number. So we're going to have a negative divided by a negative, which will essentially just turn out into a positive slope. As you could see, as we increase in our x values, as we look down this table and our x values increase, our y values increase. That means that we're looking at a line that is going up. It's an upwards line. So you could think about all these things as you work, and that's why my slope is going to end up as a positive number. But let's see what happens when we have 1992, which is my birth year, by the way, 28.2 subtracted, that we're going to get a negative 8.3 on that. All right. And then 6 minus 8.3 will give us 2.3 negative. Okay. So remember that this is going to be, let me see if this is a pretty, not so pretty. This is not that pretty. So I guess we'll go ahead and turn it as a decimal. It's okay. We can turn it as a decimal, or we can just leave it like this. This will give us 3.6. Let's just round it to the nearest 10th place, which is that. Let me just check my math again. 8.3 divided by 2.3, 3.6. Yes, correct. And it's positive. All right, we're good to go here. Hopefully you chose different numbers and you can see that the slope is the same, right? Just for those of you that don't really see it, imagine, so we had, just to give you a really quick idea, hopefully you guys can agree with us that we had we got 1, 2, 3, 4. There were 4 points on this line, and I'm just going to make them up, and they're on the same straight line. So if we found the slope between 2 points, which let's call it this, slope is the amount of tilt or the amount of steepness of a line. Well, isn't the amount of tilt of this line right here the same thing as the amount of tilt or slope of that line? It's the same line. The line tilts or slopes the same amount all the way throughout. That's why I say it's the same no matter what points you choose. All right, now here it's a little bit different. We have a word problem, and you could tell that this is different slopes. All right, these are 4 different parts, and they all slope differently. So let's see what this is talking about. The Jackson High School Student Council budget varies based on the fundraising of the previous year. So the school raises money and they use that for the next year. Part A, find the rate of change. So how much did it change by the rate? Okay, between 2005 and 2010, and describe its meaning in the context of the situation. Guys, this right here, please pay attention. This is the new part for right now. What we did yesterday and what we're doing, or what we did in the first problem that we did, is finding the rate of change, which is finding the slope. Super simple, very simple idea. So the first part, I'm going to do it in red. And then the second part, which is interpreting it. Okay, what's the story behind that number, right? So we have a number. What's the story behind that number? Okay, now that we have a story, we can use it. So let's see, 2005 and 2010, we have an X value. So let me write my X1, Y1. I'll go ahead and choose my X1, Y1 to be 2005. Let me write a little bit thinner. So, okay, the Y value of 1350. So I'm able to fit more. Okay, and then my X2, Y2 would be 2010 with a Y value of 1675. Okay, I'm gonna make sure I don't make a mistake in this one. So let's go ahead and I always will do this. I will always write the slope formula. The more you write it, the more it stays in your brain. Y2 minus Y1 divided by X2 minus X1. If you paid attention last video, you understand that we can write this formula a slightly different way. We're not just tied up to this exact formula, but if you don't remember what we learned last time, stick to this exact formula. Don't move numbers around. All right, so my Y2 is 1675 minus 1350, which is Y1, divided by my X2 of 2010 minus 2005. Okay, so what do we have here? We got 1675 minus 1350, 325. Okay, check up on that. 2010 minus 2005, that's going to be 5 years. All right, so 325 divided by 5, we can go ahead and simplify that. That's going to give us 65. We can divide this to get 65. Now remember, I always like to preach that we like to look at slope as a fraction. So if it's a whole number, just put a 1 under it. This will help us interpret it. Now, the previous video, part 1, we learned how to find slope, okay? How to find slope. Now, this video is going to be what is actually the definition of slope. What is actually the definition of slope in a story? Here it is, guys. Definition of slope in a story is the unit rate. The unit means 1, as you can see here, okay? The unit rate of whatever is, the story. So right now we're talking about fundraising money, and our X values, our time is years. So what's happening here, the answer to this, the slope is 65, but what actually is 65? 65 is the amount of dollars that is being raised every year from 2005 to 2010, okay? From 2005 to 2010. That is the unit amount every year. So let's go ahead and put it in words instead of me just saying it again. Between 2005 and 2010, the school raised. And we're saying raise because the line is going up. Not always it's raising money, because if you look at the next set of lines, they're going downwards. So raised $65 per year. Okay. That's it. It's as easy as that. If you can understand that rate of change or slope is going to be your unit, and just understand that it's your unit of this thing and that thing put together. So you're raising $65 every year. It's going up. Every year is going up $65. That's how we got from this number right here to this number right here. It went up $65 1 year, $65 1 year, $65 1 year. That's what happened. That's kind of like the base idea of it. All right, so let's continue and look at the next question. B, find the rate of change from 15 to 20. describe its meaning in the context of the situation. So as we said earlier, 15 and 20, it's a downward line. So I'm going to put a negative here. So I should have a negative slope. All right, let's do 15 and 20 here. First, let me go ahead and select my x1, y1, x2, y2. And I think it makes sense to put it in order, right? x1, y1, and x2, y2. I always say it doesn't matter which point is your x1, y1. It doesn't matter, but to keep it clean, I'm going to go from left to right. So 2015 is my x. My y for that is 1550. And then x2, y2 would be 2020 with a y value of 1325. And those people got lazy. Those students got lazy raising money, huh? Okay, so let's go ahead and see the slope on this one. Come on, board. Okay, here we go. So I'm about to grab this data set and grab the slope of it. Slope of it is found by doing y's, the difference of y's divided by the difference of my x's. If I go ahead and substitute this, my y2 was 1320 minus my y1, 15. Ooh, I didn't look like a 5 right there, 1550. X2, 2020, and 2015. Once again, a 5-year difference, 2015. So we got a 5-year difference here. 1320 minus the 1550 gives us a difference of 230. The 230, don't forget, because this number is larger, the 230 becomes negative. Okay, now that assures us, once again, look at the line. It makes sense. We have a negative sloping line. It's going down from left to right, so we have a negative slope. That number ends with a 0, so that means that it is beautifully divided by 5 by the number 46. So this becomes the number negative 46. Okay. So what can this be? How can this be talked about in the context of the situation? Remember that this graph is talking about the school's fundraising budget. So how much money they've been making throughout these years. As we said before, this is per year when we talk about slope. So what does a negative mean? What does a negative mean? Context of the situation. Here we go. The number negative 46 means that we are actually making $46 less than the previous years, okay? We are making $46 less, so we can maintain that straight, perfectly downward sloping line. It has a rate of change of 46 going down, okay? So between 2015 and 2020, they raised $46 less. So make sure you make this sound $46 less each year, right? Less than the prior year. And I know if we start to break down the grammatical sentence here, it's going to make a little bit less sense than when we talk about it. But what this means is starting at 2015, they raised, how much did they raise? The number's actually there. At 2015, they raised 1,560. If you grab this number right here, and you take away 46, remember that from 2015 to 2020, there's 5 years. If you go ahead and take away 46, those 5 times, you're going to notice that we actually get to 1325. So that is what's happening. We have been raising $46 less than the previous years. That's what it means to have a negative slope. And that is what slope means. Slope is your unit, okay? Your single unit of whatever it is that you're talking about. Right now, in the Miami Dolphins problem, we're talking about years. So it's going to be the same thing. All right, so let's go ahead and do this one. I encourage you to pause it if you haven't already done this one, and just check your answers afterwards. So this is the average ticket prices. So it's already the average ticket prices for the Miami Dolphins football team. I'm just going to underline this so we can go back to it, because I know that's going to be part of our explanation in words. A, find the rate of change in tickets prices between 2009 and 2010. All right, let's do this. I'm going to now start doing a little less explanation, or I'm sorry, a little less writing on my part and the same amount of explanation. So I am going to go ahead and go from 09 to 2010. So I'm going to go from that point to that point. I see that my Y value from, so let's call this point number 1 and point number 2. Okay, so my Y value from point number 2 is 70.54 minus the Y value of my point number 1 is 66.74. Remember that Y value is always your height. Okay, and then your X value is just pretty much right here. Okay. The Y value from my second point was 2010. And then the other one was 2009. First one. So now what do we got here? The difference between these two numbers. So we have 70.54 minus 66.74. We get 3.8. And then from this year to that year is just 1. Okay, 2010 to 29. So here it is. We got that pretty 1 underneath. That means this is a reminder again, this is our unit rate. Unit is what happens every one of these things right here. Right now it happens to be years, but it could be months or seconds or any time frame that you want to talk about, any time unit, weeks, years, months, days. So this is what's happening every year. Again, this is what you want to go to and then say this, right? So the average ticket prices are going up 3.8 every year, okay? Find the rate of change between 20, actually it didn't ask us. So let's see what part B says. The ticket prices have the fastest rate of change. Let's see. So let me go ahead and just circle this one or box it in, which is the same thing as 3.8. Box it in and move on. The ticket prices have the fastest rate of change between what years? So I need you to stop right now, and I need you to go back to the very first example of the walking man across the, across the little road, I guess I made, which was this one right here. And remember that the steepest parts of this walk, right, is what's going to make the greatest slope, the biggest number. So we're not only looking at the positives, we're not only looking at the lines that are going up, but we're taking all of them into account. Which line here has the biggest amount of tilt? It doesn't matter if the line is tilting upwards or the line is tilting downwards. We want to find which of these lines has the most amount of tilt. So let's go ahead and compare just the ones that are going up. All right, let's go ahead and compare just the ones that are going up. Look at this one right here and look at this second one right here. Hopefully you guys agree that this second one that I drew right here, it is with most amount of tilt. Even if this one is also going up, this one still takes the cake. This one wins. It has the most amount of tilt. So out of the lines that are going up, this one has the greatest tilt. Now, we actually already found the amount of tilt for that one, which is 3.8. Remember that tilt is slope or steepness. The next one you want to talk about is, okay, let's now look at the lines that are going downwards. This one is very, very slightly going downwards, and this one for sure is going downwards. So I know for a fact that this one is not steeper. the one that I just left here in red, it is the steepest downward line. What this problem is asking us to do, actually, is actually incognito, is asking us to find the slope of this one so we can compare the two steepest lines and say which one actually has a bigger number. Whether the number is negative, a bigger negative number, or a bigger positive number, which one is bigger? So this problem right here is asking us to find the slope of the red one, okay? Because we want to compare those two different numbers. All right, here we go. I already told you what we're doing, so let's get moving. All right, so I'm going to go ahead and call this point number 1 because I'm just going to go from left to right, just like a normal human being. Just kidding. We're all weird. All right, so y2 would be 65.16 minus y1, 71.14 divided by, what are the years? 2014. And the difference, 2014 to, what is that? 2013? Okay, just one more year. 2013. All right, so that's going to give us another unit. So we can easily compare them without doing too much. So 65.16, I know I'm going to get a negative, minus 71.14, and negative 5.98. Negative 5.98. Okay, so that's that, which equals to just negative 5.98. We don't have to leave the 1 there. Sometimes we like to look at it. Which number is a bigger, is a stronger number? And I don't want to ask you which number is more positive, which number is larger value, because we know that in a number line, when we're looking at a number line, the numbers that are more to the right are larger because they're more positive. So right now, if you say 3.8, you might be be misunderstanding the question. Which number has a greater pull to their side, like a tug of war? Would a 3.8 be a bigger pull? So a bigger tug of war person on the right side of the rope than a negative 5.98? And the answer is no. Negative 5.98, this right here is a stronger negative number. So that is the winner. This line right here, hopefully, visually, hopefully you already caught it on the amount of this tiltage of the line. So the fastest rate of change, the line that changes faster, the steepest line right here, is from 2013 to 2014. That's it. That's the winner. If we were to, it's silly because I saved us a lot of time by not looking for the slopes of any of these lines. We know those numbers are going to be smaller. Okay, those numbers are going to be smaller, and those are typically the smaller people that you put in your tug of war right here at the front. So they don't matter. I wanted to find the biggest tug of war challengers from this graph. All right, so here we go. Part C, between blank and blank, the rate of change is negative. Between where and where the rate of change is negative. Okay, here it's negative and here is negative. They're not asking us to find it. It is visually there. We could see that those two lines are sloping downwards when reading it from left to right. So that's pretty much the answer. So 2010, 2011, between 2010 and 2011, and 13 and 14, the rate of change is negative. Yes, it is. Bada bing, bada boom. All right, moving on. Question or example number 3, rate of change. All right, determine whether each function is linear. Oh, now we have to determine this first, which is what we did before. And I told you guys, oh, we don't really have to do it. But right now it is asked to determine if it's linear. Then if it's linear, state the rate of change. Okay, so here we go. To determine that it's linear, we want to make sure that there's an addition pattern on both the domain and the range, the x and the y. So from 11 to 8, how much is that? How many jumps do you need to get from one number to the other? That's 3 jumps. From 8 to 5, how many jumps? 3 jumps. From 5 to 2, 3 jumps. From 2 to negative 1, if you look for it, it's 3 jumps. So we're good here. We check that our domain is skip counting by the same amount. What about our y values? From negative 5 to negative 3, that is a difference of 2. There's another difference, or a jump of 2, a jump of 2, and a jump of 2. This makes it linear. So linear. Okay. Both the domain and the range have an addition pattern throughout the existence of the whole table. Now, find the rate of change. Rate of change is slope. Very simple. Choose any 2 points that you want right here and plug them into your slope formula. Okay. I encourage you to pause the video right now and let's see if we get the same answers, choosing hopefully different numbers. Let's do it. All right. So I'm going to go ahead and choose 2, 1, and I'm going to call that my point number 2. And I am going to call this one my point number 1. Okay. So here we go. Let's see if your numbers and my numbers are the same at the end. So my y2 is 1 minus -3. So since I'm going to write -3, I have to put parentheses, -3, divided by my x2, which is 2, minus 8. Okay, so this right here is everybody's Achilles heel, which is you guys freak out when oh man, the little circle. When you guys see a minus negative. Remember that a minus negative is the same thing as adding. So I don't even know why I wrote that. I was supposed to write a 1. So 1 plus 3. These two will team up to make 1 plus 3. Okay, I'll just go ahead and write it. That's going to give us 4 over 2 minus 8, -6. What can you divide both of these numbers by? You can divide them both by 2. That is going to give us 2 over 3. Don't forget that the fraction is still negative. Here you go. Now, does it make sense that my slope is negative? Does it make sense that I have a negative number at the end? It should make sense when you look at the table and notice that as my x numbers are going down, my y numbers are going down. So this is a negative function, okay? Just to give you a quick sketch right here for those of you guys that are a little visual, as your x numbers, look, as you're going this way on a graph, your y numbers are going down. So look. As you're going more to the left, as your points are being created more to the left, they're also being created, not only as they're being created more to the left, but they're also being created down as well. So as they're created to the left, meaning less in your x's, they're also being created less in your y's. So, oh, wait, I just made a, no. I just proved myself wrong. Hold up. I just did this. Good. Well, that's good. That's good that I said this. I proved myself wrong. This is going, whatchamacallit, upwards. This is going upwards. My y's are going up. Because starting at -5 and ending at 3, we're going up in our y's. Oops. And hopefully you notice that this line right here that I created, I just made a dookie out of myself. I just created a positive sloping line telling you that it was negative. This is perfect. This is called error analysis. But this is how you can just make sure that everything you're doing checks off. Everything should have the same pattern. So as I was saying before, sorry to have to do this again. Your x numbers are going down. Yes, they are. Oopsie doopsie. They're going down. Boop, 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 boop. So as we're creating points that are to the left, more to the left, the points, the y values are the y values for your points, as this suggests right here, are taking us upwards. So up. As we are creating points that are more to the left, their y values are higher and higher. This creates a downward sloping line. I look like a donkey. All right, go ahead and try this question. Pause it, try it out. All right. What do you notice? We need to notice here that, let me make sure first if they're asking us to, if it is. Okay, so we need to make sure that this is, linear first. So from 22 to 29, how much is that of a jump? That's a jump of 7 units, okay? From 29 to 36, that's 7 units. From 36 to 46, 6, 7, 8, 9, 10, 11, 12, 13, that's 7 units. And then from here to here is also 7 units. Okay, so far our x values, our domains, do have an addition pattern. Jesus Christ. All right, so from this number to this number is a jump of 3. From here to here, from -1, we got to go to 0 and then 1. That's a jump of 2. Ay, ay, ay. And then from here to here does have a jump of 3, and here to here has a jump of 2. So this is not linear. We do not have a consistent addition pattern in our y values here. So therefore, this is not a linear function. Since it's not linear, we can't really determine a rate of change. It won't make sense to do a rate of change here or find a slope. Imagine that this looks like this, right? It's not linear. This is not linear. And we have 1, 2, 3, 4, 5. And rate of change is, we find it to kind of get an understanding how something is increasing and how something is decreasing. It doesn't make sense for us to find the rate of change from here to here. Like, remember that rate of change is found by a straight line. So it wouldn't make sense for us to find a rate of change from this point to this one, because that's not really what's happening. That's not the story of this curve. The story of this curve is going, it's going upwards like that. Okay. So can we actually find the rate of change of 2 points that are next to each other? Yes, we can. And then the next 2 points that are next to each other. Yes, we can. As you could see, even though these are not, the original is not a straight graph, what we're doing here kind of very, very closely resembles the pattern that this curve has. So we could go in order and find the rate of change between these intervals like this. Notice that I'm overlapping colors because that's exactly what you would do. Okay, so we could, but right now it's saying if it's not, or I'm sorry, only if it is linear, then find the rate of change, but it's not, so we're not finding it. All right, I'm not going to explain this one to you. I want you to go ahead and try it on your own. It says complete each table so that the function is linear. You now understand, you should understand what linear means. So pause this sucker right now and try it out. All right. So let's go ahead and check our work. Remember that for something to be linear, there has to be an addition pattern consistent throughout the table. So skip counting has to be the same. As you guys could see here, what is the pattern from 8 to 11, 8, 9, 10, 11? That's a difference of 3. From 11 to 14 is a difference of 3. So what would be the number that needs to go here as a difference of 3? That would be your number -5, okay? -5 and -2 have the same common difference of 3, all right? Now we have to take that same idea and take it to the y side. We need to create the same pattern of addition that's happening here. Now from 2 to get to -5, that's a jump of 7. Okay, a jump of 7. If we want to go up the table, that means we're adding 7. Okay, that's an addition that I did there, by the way. Jesus Christ. If we want to go up the table, we have to. I'm not trying to grab the eraser. Okay, once again, going up the table is +7. Going down the table is -7. That's the pattern that we have here. So 2 + 7 will give us 9. 16 + 7 will give us 23. Hopefully we got all of that correct. If not, feel free to ask me for that. Guys, we're going to go ahead and do the same thing on this side. You could see that your X or your domain values or your input values, we're going down by halves. But it's actually easier to look at it because most of the information that's given to us, it's already at the bottom. So look at it going upwards. So we're going to be adding, as we go up, we're going to be adding half. So 9.5, 10, 10.5, 11, 11.5, 12. Okay, so that's what's happening here. On this section, we could see that the difference would be 325. 325 is going to be the difference between the two consecutive numbers in the pattern that have been given to us, this one and this one. So you can also see that going down our X values, we're adding the 325. So 1 plus 325 will give us a 425, and then 1075 plus the 325 will give us the 14. Hopefully that made sense. If not, you can always pause it or ask me additional questions on that. All right, so moving on. Example 4, slopes of lines. This right here is going to be your classwork. So go ahead and complete this problem right here. Let me go ahead and tell you right now how many you need to complete. You need to complete your example 4, A, B, C, and D. As you can see, A is very simple because the graph is given to you. So very visually, you can find the slope of this line. On the other note, you have B, C, and D, which the line is not given to you. The graph is not given to you. You are supposed to use the formula, okay? Try not to graph it. avoid graphing it, okay? Now, determine the slope of a line passing through the given points. If the slope is undefined, write undefined. Write your answer as a decimal if necessary. Ooh. So, pause this sucker right now and get it done. All right, let's do this. We know that slope of a line is y2 minus y1 divided by x2 minus x1. Okay, which point do I want to call my point number 2? It doesn't matter. You know what? I'm going to mix it up. I'm going to call this my point number 2. I'm going to call this one my point number 1. I'm going to switch it up. So my y2 becomes -4. That means I have to subtract 1 from that. My x2 is 5. That means I have to take away 0 from that. -4 minus 1, they're both in the same team. They're both negatives, so that gives me -5. Here we have 5, take away nothing, which is just going to leave me with 5. Anything divided by itself is 1, and a negative divided by a positive is negative. Here we go. So, if the slope is undefined, write undefined. Did we get the correct answer? Bada boom. Yes, sir. All right. Here's the caveat. I needed you to pause this right now. I haven't really taught this to you yet, but I'm sure the information, no, I'm not sure. I know for a fact that all the information that you need, you already know. This is just another way of asking you a question about slope. Pause it right now and try it. All right, guys. So what is this question doing? This question is saying, here's a point, -4, 5, and then there's another point, +4, r, which we don't know what r is, and it has a slope of 3/4. What is the value of r? So what we want to do here is pretty much the same thing that we've been doing, but there's just hidden information. So this is what we're doing. Okay, same thing, nothing changes. And let's just go ahead and find where the missing information goes and put it in so we could actually fill it up at the end. All right, so we have, let's call this, you guys want to call this 2 or 1? Doesn't matter. I'll call this 2 and I'll call this 1. Doesn't matter. So my y of my second point is 5, subtracted by the y of my first point, which is r, divided by -4, the x of my second point, minus the x of my first point. Okay, so here's what we need to do. We need to find out, and I'm going to go ahead and leave a blank right here, because our solution has to be 3/4. We already know the slope. It's already given to us. So we have a blank here, which is like, all right, well, what does the r need to be? What does r need to be so that this step becomes this right here? So let's first go ahead and do the bottom because we don't have information for the top. Let's do the part that we do have information for. A -4 and a -4. That's going to give us -8. Ooh, okay. So what does that give you? What information does that give you? This -8 needs to turn to this number. Okay, so that should ring the bell in your head saying, okay, the 8, or I'm sorry, this fraction, the fraction that we start with gets reduced, gets simplified into a 4. So that means that we're going to be dividing this by 2, So the number that we need to get here is what? What number do we divide by 2 to get 3? That's the number 6. Okay, that's step number, whatever step that is. So what number do we take away from 5 to get 6? Dum, 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 dum. What number do we take away from 5 to get 6? All right, so this one should be tricky and should be a brain grinder, but I need to stop you right now because this is what's going to happen. So this is your thinking right now. 5 minus what number has to give me 6? Now, if you use the algebraic step that I've taught you in the past, which is just take the 5 to the other side, this cancels out. Now you have -r equals 1, take negative to the other side. This right here. Now we have, I'm sorry, I don't know why I crossed these, the 1 and -1. This is what we have to the other side. We took the negative to the other side as the last step. If you don't see it, look at this. What's 5 minus a -1? When you do minus negative, remember that you're actually adding, okay? So that's giving us 6. But you need to stop right now and say, is that actually the number that I'm looking for? Am I looking for a number that's going to give me a positive 6? Did you catch this little tiny thing that I did not give you? Think about it. If you still want to think about it and challenge yourself, pause it. All right. Look at your final solution. It's a positive fraction. It is a positive fraction. It is a positive fraction. The 8 that was that we got from here, it's negative. It's a negative 8. So that means that we don't need this number to be actually 6. We need that number to be a number that's going to make our final solution a positive. And the only way we can do that is having a negative divided by a negative. Yeah. So that changes now the way that we're thinking. Now we're actually looking for the number that when we take away from 5 will give us negative 6. Now let's go through the movement of this same exact thing. We'll take 5 to the other side by subtracting. Oh, I don't even know why I put 6. My brain is already ahead. So this cancels out. We now have negative r. Don't forget your negative. We'll take that to the other side. And this will give us negative 11. As we take this negative 1 to the other side, cancel the negatives, r is equal to the number positive 11. What? We didn't have to do all this because now the thinking gets a little bit easier. 5 minus what gives you a negative number 6. And that would be the number negative 11. Okay, let's check right here. Hopefully I have, do I have it? Do I have it? Do I have it? Maybe not. Sorry, I just remember that maybe I did or didn't. The number is not negative 11. The number is 11. 11 is what r needs to be to make a 3/4 positive. Okay, you don't want to put a negative 11 in here because then there's already a minus from the, whatchamacallit, from the formula. All right, so this is where we're going to stop from this video, part 2. Peace out.